Okay, so now we're on the top of page 239, and example 4 says that you're going to estimate the limit numerically and then graphically, but before you do so, can you change it so that it does not say x approaches 0? It needs to say as x approaches 1. So what you need to do is pause the video, and you and your neighbor need to try the problem and then restart the video so you can see what the answer is. So if I'm going to approach 1, from the left-hand side, I'm going to have 0.9, 0.999, 0.999, things that are really close to 1. And I get 1.81, 1.98, and then what my calculator said was 2. And then on the right-hand side, I'm going to have 1.1, 1.01, and 1.001. So 2.21, 2.02, and 2. And when you look at the graph, you had what was a parabola, and I would hope that you would remember from rational functions that if you divide this in, you're going to have a parabola. So when you do that, you do get a parabola, but if you were to zoom in on your graph, you would see right here at 1, and really the ordered pair is 1, 2, you have a hole. There's a hole in your graph. Well, that doesn't mean the limit doesn't exist. What that means is that because you approached it from the left and from the right, and both sides of the table both say the answer is 2, then the limit of this function as x approaches 1 still is 2. Okay, so now we're going to try the next problem. Just so you know, these are, it says f of x equals 2, comma, and then f of x equals 4, comma. So I'm just going to kind of draw a quick graph. F of x is a fancy way of saying y. So 1, 2, 3, 4. If I were to graph this, it says that f of x is 2. Except right here at 3. And then it says f of x or y is 4 only at 3. So that's what your graph looks like. Take a moment with your neighbor and discuss what you think the limit of that function is. Okay, so here's the deal. Just because there's a dot right here, that doesn't really have a lot of bearing on the limit. If you were to look at this graph from the left and from the right, if you're looking towards this point, as I get really, really close to 3, both sides of my graph say that I'm going towards 2. So the answer to this problem is also 2. And no, the limit is not always 2. It's just a coincidence that the last 3 problems all had the answers of 2. And then we get to your quote-unquote favorite Mean Girl quote ever where they say the limit does not exist. And so we're going to do this problem down here where it says the limit does not exist. And so you can make a table. I find that graphing it is easier. And to graph it, you probably are going to need to make a table anyways. So if I were to plug in numbers, like if I were to plug in -1, the absolute value of -1 is 1 over -1 is -1. And 1 over -1 is -1. If I were to plug in -2, you're gonna get a 2 over a -2, which is still gonna be -1. And at this point, I bet you can see the pattern is that this is gonna kind of be like this. So. And this is going to happen until I get right here. I can't plug in 0, and here's why. If I plug in x equals 0, I'm going to get undefined, because a 0 over 0 is undefined. So this is going to be an open circle. And if I try some things over here, like 1, if I plug in 1, I get 1 over 1, which is going to be 1. Same thing with 2, 3, 4, 5. Again, you can't plug in 0, so open circle, and your graph looks like this. Sorry, not the world's best drawer. So I look at my graph. If I'm going towards this point from the left, like this, I'm going towards 0. Sorry, I'm going towards -1. And on this side, like the graph itself is going towards -1. And if I go from this side, my graph is going towards 1. So this graph is going towards -1. and this graph is going towards 1. So as my x values get closer and closer to 0, my y value becomes really close to -1, and as my x values up here get closer and closer to 0, my y values get closer and closer to 1. Well, because these two sides are not the same, what we say is that the limit, we write DNE, or does not exist because the two sides do not agree. So at the top of the next page it says conditions in which the limit does not exist. So if you have some limit f of x as x approaches c does not exist if the following rules or conditions are true. If f of x approaches different numbers from the right and from the left side, that's what we just did down here, then the limit doesn't exist. If one side of the graph increases and the other one, if one side of the graph increases or decreases without bound as c approaches x, then the limit does not exist, which is what we're going to talk about right here in a second. And then f of x oscillates, or which means it kind of jumps back and forth between 2 points as x approaches c, which is going to be example 8. So now let's do example 7 and example 8. So if you can make a table or you can graph this. I'm going to go for the graphing approach because I know what this looks like off the top of my head. And so when you graph this, it does this thing. It's one of our rational functions. And so as x approaches 0, if you go from it this way, this graph is going, this side is going towards infinity. And if you go at it this way, it's going towards infinity. We can't have a limit of infinity, so this limit also does not exist because it's going to grow without bound. It's going to keep getting bigger and bigger. Okay, number 8 has that tricky word and it oscillates, and what oscillates means it kind of jumps up and down. So what we're going to do for this graph is, let's look at the picture of it. So I'm going to grab my calculator and I'm going to graph it. I'm going to graph and when you graph it you get that, and I'm going to do menu, zoom in. And so I've zoomed in and I'm going to zoom in again so you can see it. So what you can see is that my graph, it's going to go up, down, up, down, up, down, up, down, but it's never actually going to stay at 0, because you know that the sine wave, if you think about the sine wave, it starts here and it goes up, down, and so that's what this graph is doing. So because this graph oscillates, it doesn't really approach one thing, we also can say that the limit does not exist. So now you're going to go to the next page and go back to Edmodo and watch the next video.